Good morning, everyone. So today we're going to be learning a little bit about friction. So we are going to be doing two different experiments. And so one we're going to be using some rice and chopsticks, and the other one we're going to be making a hovercraft. Let's get started. So for this experiment, we're going to be putting rice into this glass bottle, and then we're going to be putting chopsticks in it to demonstrate friction. So I'm going to use this funnel to put the rice into the bottle. So the slower you go, the less likely the rice is going to get stuck into the funnel. But if it does get stuck, you can just bang the funnel and the rice will go through the hole. So I'm going to fill the bottle right up to the top. See, I went too fast and I got stuck. We just shake it out. Away we go. So I'm going to talk a little bit about friction now. So friction is a force that restricts or stops the movement of two solid objects sliding along each other. The force of friction acts in the opposite direction of a moving object. When two or more objects rub against each other, they cause friction where they touch. We'll fill this up. So the next thing we're going to do is bang this bottle down and get the air pockets out from around the rice, because that is going to make it so that friction doesn't work if we have too many air pockets. So let's bang it on the table. So if you notice, it's already moved down a little bit. So it was full up to here, and now it's moved down with the air pockets. Let's move down some more. So I'm going to add a little bit more rice to the top. And then I'm going to bang it one last time. And then we're going to take our chopsticks and we're going to put them into the bottle and push them all the way down to the bottom. And it's really hard to do, and that is because of friction. And now I'm going to move this tray out of the way so you can see. I'm going to pick it up so it's floating. And so the reason this works is as we push the chopsticks into the bottle, the grains of rice settle close to one another, eliminating most of the air pockets. Once this happens, the frictional force overwhelms the rice, and the rice will push against the chopstick. In fact, the grains are pushing so forcefully, they create a force that causes the chopstick to become stuck, allowing us to pick up the bottle of rice. So now I'm going to show you what happens when we don't get rid of the air pockets, because I forgot to do that before. I'm going to pour it back in. So this time I'm not going to bang the bottle on the table. So if you notice, because I haven't banged it and there's air pockets all around the rice, friction is not occurring so that I can't lift the chopsticks. But if I bang it down and get rid of those air pockets, it's gonna work again. And then friction is allowing us to pick it up with the chopsticks. So let's explore some examples of friction and some fun facts about this phenomenon. It is a strange phenomenon that two rough surfaces can experience so much friction that they stick together. For example, two pieces of sandpaper. And then in contrast, two very smooth and polished surfaces can also stick together. For example, two pieces of highly polished and clean glass. Scientists have tried to make up rules for friction, but for every rule they have found exceptions. What they have determined is that there are two types of friction, static and kinetic. We find static friction happens when two objects are not moving, and kinetic friction happens between two objects that are moving. There is friction in liquids as well. Friction operates between the layers of a liquid. This is called viscosity. The more viscosity, the thicker the liquid. For example, honey is more viscous than water, and oil is more viscous than milk. If you are running and want to stop, the friction between the soles of your shoes and the pavement allows you to stop. But if you try to stop as you hit a puddle, you will slide because the water on the pavement lessens the friction by making the two surfaces smoother. Have you ever heard of a car hydroplaning? This is the effect of friction being reduced by water or on any liquid on the road. The use of the logs and the invention of the wheel was one of the ways man tried to reduce friction and make an object move more smoothly. Friction also generates heat. If you rub your hand back and forth quickly on the carpet, you will feel the heat caused by friction. The force of friction can also cause objects to wear down or wear out. If you constantly use the brakes of a car, eventually the brakes will fail because the material on the brake drums have been worn away, resulting in metal touching metal. This can result in a screeching sound. Friction can be reduced in moving parts of any machine. A lubricant, such as oil or grease, is used to stop gears and other moving parts from wearing out and stop moving altogether. This is why wheels are packed with grease and why oil is used in car cylinders. So this is a hovercraft. A hovercraft is a vehicle that glides over a smooth surface by hovering on an air cushion. Because of this, a hovercraft is also called an air cushion vehicle, or ACV. How is the air cushion made? The hovercraft creates vents or currents of slow-moving, low-pressure air that are pushed downward against the surface below the hovercraft. So modern hovercrafts often have propellers on top that create the air currents. These currents are pushed beneath the vehicle with the use of fans. Surrounding the base of the hovercraft is a flexible skirt, also called the curtain, which traps the air currents, keeping them underneath the hovercraft. These trapped air currents can create an air cushion on any smooth surface, land or water. Since a hovercraft can travel upon the surface of water, it is also called an amphibious vehicle. So today we are going to create our own mini hovercraft using a CD, a pop-top lid from a drinking bottle, and a balloon. So we are going to make our hovercraft today. So I'm using an old CD, and then I found a pop-top, and I've already hot glued it onto the top. So if you're going to do this by yourself, then you're going to probably need an adult to help you hot glue the top on. Now I'm going to put some tape on the bottom of the CD that covers the hole, and this is to control the airflow. And then I'm just going to poke a few holes into the tape to control the airflow from the balloon. So to give it some stability, I've just realized it's moved a bit, so I'm going to tape my lid on a little bit more so that it stays in place. I'm going to tape it all around to make sure it seals. The glue isn't a very good seal. It helps it stay on, but it doesn't seal the air around the lid. So I'm going to blow up my balloon. twist the top, put it on here. Twist it around, and then it's going to float around. I'm going to make it on the surface. So it floats around as I push it. That's kind of fun. It was floating on the top. We'll do it one more time. So see how it's sliding across the table really easily? That's the air pushing on it. So an object gliding on the table stops because of friction. So see how it doesn't move as much, but with the air it was moving around? So when friction is reduced, a gliding object moves faster, farther, and for longer. So this balloon hovercraft can fly across the table because air has less friction than the table. When pressurized air escapes from the hole in the CD, it creates a layer of air cushion beneath the CD. So the hovercraft glides on air instead of the table, and it can go much faster and farther than if you just push the CD alone. See, it doesn't go as far as when it had an air cushion underneath. So a real hovercraft and an air hockey game work based on the same principle as this. A hovercraft uses blowers to produce a large volume of air below the vessel to allow it to travel at high speed. An air hockey table produces a cushion of air on the play surface through tiny holes so that the pucks can travel quickly and freely to allow you to score. I hope you guys had fun learning a little bit about friction, and we'll see you tomorrow. Bye guys!